And we're on the air. Hello, friends. Welcome to another Codementor Office Hours. My name is Mark. If this is your first time checking out Office Hours, basically what we do is we have on different experts about all different technologies that we're really big fans of that maybe they're not getting covered enough in the tech news, or a lot of developers in the community are having difficulty with it. And we try to find some clarity and just learn a lot and kind of contribute back to the community. So today we're really excited to have on Alex Collin. In terms of format, I'll give Alex a quick introduction and then he's going to give a presentation. But if you are joining the live room we're in, you can throw questions into the group chat. If you're watching the live broadcast, there's a Q&A app on the side and I'll get notifications about that. And we'll try to hit as many questions as we can at the end. But without further ado, Alex Collin is a customer solutions engineer over at Algolia, an instant search API that enables developers and businesses to integrate really great search experiences into their applications without needing to be search experts. He has past experience as a software development engineer over at Amazon, studied at Paris Dauphine University, and received a master's degree in computer science. Today, Alex is joining us from Paris, and he will introduce the must-have tools for creating an engaging search experience, such as multi-category autocomplete, instant faceting, and ranking strategies. So please welcome Alex.
Hi guys, thanks very much Mark for the description, really good, and thanks for the invitation, being here, having the opportunity to give more info about search experience and how to build an engaging search experience on his own website or mobile app. So I'm gonna share my screen. Can you see my screen right now? Yeah.
Yep.
All right, perfect. Sounds good. So the subject of this Codementor today is leveraging search to build an engaging user experience. So Mark already introduced me, but quickly I did some product marketing, work as a software engineer at Amazon, went for traveling and work as a freelance. It was a great time. Recommend anyone to do it. Really good. And since almost 1 year, I've been working for Algolia as a customer solution engineer, where my scope includes build prototypes, provide technical support regarding tech questions, but also implementation in terms of user experience, share best practices, and above all other things, ensure that all our users are successful and you guys are successful. So that's my role. So quickly about Algolia, that's a company which has been created 2 years ago by two search veterans. They built a mobile SDK to provide search on any low-powered devices. And after a few months, they just decided to bring this instant search engine to the web by providing it, making it available through an API. And it's when we release a hosted API. Since then, we've been to Y Combinator and released our distributed search network that I will talk about a bit later on. Just to give you an idea, today Algolia it's more than 500 customers in more than 45 countries, a team in Paris and San Francisco, and we're delivering search for e-commerce websites, for media, and lots of other kind of websites, any apps, any application having a need of search on top of a database can potentially use Algolia. So quickly about the agenda for today, we'll cover during 20 minutes the state of the art of search, and then we're gonna dig together on how to build an instant search and navigation user experience based on what we will see in the next 20 minutes. So that's for today. So state of the search, state of the art of the search. So today what we see is, I'm pretty sure you guys are already familiar with that, but just in case, so there's two main types of search on the internet: website search, and that has been mastered for many years by Google, and site search and mobile search on the right side. They both pretty similar in the way the user interact with, but different by nature. Basically, what we can say is for website search, people are more searching for pages, documents, and in terms of search engine behind the scene is best engines work more like checking the number of occurrence of each word available in the document and checking, trying to rank all this based on the number of occurrence and that based on different algorithms like TD-IDF and so on. For site search and mobile app search, the type of objects which are searched are completely different. Most of the time they're small objects consisting in multiple attributes, and searching the number of occurrence of a word within those different attributes doesn't make that much sense than when you search for a website or a document, because for instance, on LinkedIn, if you search many times my name, I mean, if you search my name and it appears in many attributes, it doesn't make it more relevant or for me as a user searching for something. What will make it relevant will be any other popular attribute that I have as a website builder in my database, like the number of connections I can have or the number of followers that follow me on the platform. So that's for social websites, but on e-commerce website, it's exactly the same. It's not because when I search iPhone and there is the word iPhone 20 times in the description that it's relevant, but rather than if I say that the popularity of my record is the number of sales that I've done on this item for the last 30 days is the popularity, so then I can clearly see that if there's a match and the popularity is high because I've done a high number of sales, then it's popular. And that's the main difference between website search and site search. And site search, most of the time, all this information are within your database or the database of the website and not crawlable by any scraper or crawler. So that makes them different. And today, in terms of user experience, we're going to more focus on site search and mobile app search. But to do that, we're going to we can go on 3 different websites I picked today. So IKEA.com, CNN, and Amazon. They all have different search engine. So if we start with IKEA and I search for lamp, you can see that you first get like the first level autocomplete, which is not really clear because sometimes it's product, sometimes it's like a category of products, so it's not totally clear as an end user for me. And the search field is like on top of the page, so it's visible, it's clear, so that's good. And then let's imagine, so I get some lamps and I like to get some blue ones. And what we see is like today, at least on IKEA, when I search for blue lamps, I get couches, which on some point like does not make much sense. And if I start typing, like let's say I misspelled the word or I just inverted letter because I'm typing very fast, you just see that there is no result, which is for an end user quite disappointing and doesn't really help me in my search. If I have a look now in a complete different website, which is CNN, more dealing with media stuff, and I search for Barack Obama, let's say. It's pretty hot topic. The autocomplete here we see is the one provided by the browser. The only reason it get displayed is because I've done the search before to prepare the office hour. So here I get results, can search for lots of different things, which is great. But I mean, like, so the results are pretty blurry. I don't really see what I can try. I have a quick description, but don't really. Here I can see that it seems to match Barack Obama, so it seems to be fine. But let's imagine now that I don't know how to spell his name, and I try to search for Barack Obama, the way I pronounce it, and then I get a great feature here, which is, did you mean Barack Obama? So maybe it's the right writing. So I click on it, but I just get redirected to another suggestion, still no results, same and same. So here we can see that at the end, the user experience is not that as great, but that could be, or what we used to. So that's for CNN. Let's check another website. And let's see how people which has been performing on internet and focus on the internet for many years now are performing with search. So if I search here iPhone case, I can already see that I get a first level of autocomplete, which is pretty responsive. Different added information about the model I can search. And if I search blue, I get iPhone case blue, which is great. And then now if I misspell something, I still get results. I get suggestions, I get results, I get a very easy way to filter different results. I can search for iPhone cases or iPhone 6. So looks pretty good. So here what we can see for the search is results are not always relevant, and search on website looks most of the time broken. At least don't meet user expectations that are set very high by Google, Amazon, and other web players, and to which people get used to. Because I mean, I use Google for search. You probably use Google or Bing or any other search engine. We use like Spotlight on Mac. We use instant search on our smartphone and so on. So we used to all these experiences, and actually we don't find them on most of the website. Like, so yeah, search seems to be broken except for big actors that seems to have invested a lot of resources into it. So here, if we take this example of Amazon more in detail, we can see that Amazon in 2001 was offering a search field next at the same level as the category browsing tree. They did put as much effort on both. And now here what we can see is like they just decided to do it in totally different way. They just realized based on the different studies that people prefer to search. I mean, like people are lazy, and myself first. I mean, I prefer rather than start digging into the different categories, browsing and not knowing where to go and so on. Just start typing just a few keywords and see what gets offered to me. So that's why they just they push that much the search field, and that so yeah, they push that much the search field. But in order to be able to do that, they invested lots of resources, as I said before, and energy. And this kind of user experience is great only if you can do a few things. First, provide a good search in terms of speed. Google and Amazon are talking a lot about that on the internet, and more especially Google, to say that speed matters, and that they said that for them, half a second delay caused 20% drop in their traffic. That's not only for search, but that also applies to search. For Amazon, every 100 milliseconds of latency causes them 1% in sales. So we can really feel that instant speed is really important. Speed matters, and speed is one of the things we never compromise on. I mean, like, and websites shouldn't compromise on, because like the bad effect is so important that no one should never compromise on speed. Second things when you deal with search is, of course, relevance. Relevance is critical. The lack of results or the lack of relevance create disappointment to the user. If we step back to my previous example on CNN, what a regular user will do is, if I don't find anything, what I will just do is, well, I will press back, go to Google, or go straight to Google. So it's what I would do now. So I just switch to the English version. And here I'm going to search for Barack Obama in the same way. So first I get here instant feedback to say that's probably not the right spelling. And even with my current spelling, what we can see is like Google is able to provide me results, which is great, because actually it's what I'm looking for. And if I start digging into different results, actually, like if I get some news, like I may end up with on a different website. Like for example, here, if I click here, I may end up on something else. If I so that's basically actually the result here initially was BBC, but since Google identified and Google learned of the result I clicked and have been, it just changed. So let's say Barack Obama, Cuba, and that brings me to BBC. So basically what we see is like people go back and forward between the websites that not meet their expectation in terms of search and navigation. And they do that with Google because what they add with Google is they can trust Google. Google always provides the best result for them. They understand them even when they miss little things. That's called pogo sticking. Of course, user experience is bad in this case, and it ends up with a high bounce rate and a loss in investment in the SEO and SEM. I mean, like people invest lots of money to get people to get user on their website. So why should they lose them so quickly? So maybe there is something to do as well in terms of search and relevance. And relevance is critical for that. And that example with Barack Obama also applies to hundreds of millions of search queries made every day. That's an example extracted from Google. They shared on their blog that for the query Britney Spears, they identified almost 600 different ways people were using to find this artist. Some are crazy, like you have Britney Spears, or Britney Spears. There are lots. I don't have the whole list here, but there are almost 600 ways. And we can see here that typo tolerance is not just like a nice to have feature, it's a must have. I mean, like people make some typos, they don't know how to spell things, they try to spell them phonetically and so on. And based on what we've seen on the previous website, like CNN or IKEA, I mean, this big website doesn't seem to have this mandatory features that Google provide today and other web players have built in their product. And we can like easily wonder what about mobile, because we do more and more search on mobile. I've seen a recent article saying that people like it's ridiculous. They spend almost all their time on mobile and perform all the searches. And on mobile it's even more true actually. It's like you first have this need of instant, and based on this study from Google, like people when they search something on mobile, they need it now, and 55% of the consumer using mobile to research want to purchase within the hours. If they don't get the response rate very quickly, can find, refine, search, explore, and so on, they're just gonna give up and just not gonna work, and maybe get back to a old search engine like Google, and potentially for the website mean the possibility to lose a user and to get him redirected to a competitor. And there is also the fat finger effect. Everything what I was saying like about typo tolerance and so on is even more true on mobile, because everyone knows that when you type on the mobile, it's more like it's quite likely to do mistakes and to just press the key next to the one expected. So yeah, all this problem we see on desktop are even more true on mobile. So based on that, we see that building a Google-like search experience is really hard. And today has been for Google, it has been made possible because they have in-house expert, in-house solutions. They have invested lots of money, same as Amazon. They even have like their own team called E8 for search. And what we see is like big company, they manage to invest lots of money and put focus on that. But search is not something easy to implement. It's something tricky, and most developers have convinced themselves that finally it's not that important because it's tricky, so they prefer just to hide the search field or not to make it too visible. But user experience is actually something really important, and it matters for their user and actually at the end for their business, because if their user don't like the website or don't find what they're looking for, they just like go ahead and try another way. And the way how people other than web players, big web players, have been doing today, they just rely on community projects, mostly based on the Lucene search engine, like Solar or Elasticsearch. And this solution have historically been designed for document search. It's a comparison I did at the first slide. So document search, it's different from site search, and the need is different. Thus has not been designed for instant. So of course, some people are expert and can tweak it and make it look more intuitive, interactive, but it's still not instant, and it's not as good as what the web player can offer today. So it's in this context that Algolia search engine has been created. As I said before, it has been developed first on a mobile for a mobile device with mobile constraint, and that allows us to have today an unfair advantage and to have an ultra-fast search API, which returns results up to 200 times faster than the competition, enables anyone to build real-time search experiences. So we have a main focus on speed for both speed for developers and end users. And I'm gonna show you right now how it looks like in terms of user experience when you focus on speed for the end users. So here I go on this demo of an e-commerce website. They do fashion stuff. They actually have their own implementation, which is close to this one, but is different on some point. So when I search for Louis Vuitton, you can see here that every time I type a new letter, I just get an instant feedback, and I even get a feedback or results I'm looking for, even when I perform make a mistake in the search. So here, when I was searching for Louis Vuitton, you can see that that's not actually the right way to spell it. But as a user, I don't really care. I still want the result. So here, the engine API is just able to return the right result based on what has been typed, and I can even go a step further and say I want Louis Vuitton scarf, and I get the scarf, or I could get the wallet. And here, what you can see is the nice thing is like you're not only searching for keywords or search queries that have been performed before, but you directly search for what matters to you. You search for products, but you also search for categories and potentially for brands as well, according to what you type. And here what we see is like results get sorted by relevance, but also by popularity. So here within the brands, brands get ranked based on the number of products within a brand, and for the product, it's something else. It's like the number of sales, I guess. I don't remember what the data set is. So that's the first use case, which is multi-category autocomplete. Some other websites do exactly the same. Here on Birchbox, if I search, that's the French version of Birchbox, they sell cosmetics. Here, typing PIU, you can see I can search product brands, and I can even search for Paul and Joe, and without having no idea how to write it. So here, even with Anne as a word and not as a letter, and Joe like in a completely different way, I can still find what I'm looking for. If I just remove a few letters and now I just click on perfumes, you can see that then I can just go on the result page and just start refining the different things. So here it serves two different searches, two types of search. So as a user, I can decide to search straight for product. Basically, what I want at this point is like to go straight to the product I'm looking for and buy it. And in some other cases, I just want to search for some product, but I don't really know which one I'd like to. So I can start searching by categories and brands. That's a way which is offered today, but that could also point to any other resources. So that's for the first type of implementation that we call instant autocomplete. Some people decided to go a step further and to just provide what we call instant search. So what they basically do is instead of offering in their search field on the home page like autocomplete like other websites do, they actually offer the possibility to the end user to search directly for the product he's looking for. So here I can search for iPhone case blue, and you could see that I can have it like as I want. I could search for iPhone case red, and at every of my keystroke I get like all the product that get refreshed, but not actually only the product, but also all the facets. So here, everything you see on the left side, we call facets in the search industry, and they actually filters that enables the user to just refine and drill down to the result set in order to find what he's looking for. So here I can say I want iPhone with that, and you can do that, and then you also get out of the box pagination and all this feature. So we'll see just after the presentation how to build this kind of user experience very easily. That works for e-commerce website, like here, where you can say pens blue, exactly the same way, and you get all the blue ones, which is pretty awesome as a user. Very good user experience, very engaging. That works also like on any other type of website. Here we built a demo on TED on top of our API. We just took the data on top of our API and built a new search experience. So here, if I search for body, you can see that I search for talks, but also for speaker based on their names, description, or eventually for playlists. I can reorder that all based on different type of ranking. So here I can get the most funniest, the funniest talks actually. And I can even like here say, oh, I only speak German, so let's only add the one that are in German. And that's actually exactly the same things. That's our facets, exactly the same thing that we were showing before, but done in a different way. Same for here, Barack Obama, and then I get search. So that's basically the new kind of user experience, really engaging, that can be easily built today on the internet. And that leads to more engagement. Actually, we have lots of customers that see more engagement, and that was the result is also like they increase their number of sessions, like on mobile, the serve depth, decrease their bounce rate. For Birchbox, for example, they have managed to increase changing the search, the average order value by 12% and the conversion rate by 9%. So it has a huge impact on the business as well. And for a more media website like Growth Hacker, they just increase their volume of search by 5. Visitor who perform searches just they view 3 times more pages per session and spend 6 times more longer on these pages and content, which is, I guess, really good, since like most of the best websites want to get more traffic and want people to spend time on the content they publish. So that's the different things. So I'm sure you guys now are wondering how you can potentially build all this search experience very easily. So that's the second part of my talk. Basically, here using Algolia, as I said before, we have API, and it's a 3-step process. First, you import your data using an API client on top of the REST API. Secondly, you just customize ranking and fine-tune results. It's pretty easy. We'll see that later. We have a UI and just a few settings to set up, but it's, yeah. And the last step is build a search user experience. And that's really the main idea. Like, until now, people had to spend 80% of the time on the heavy lifting, on hard things, and so on, and just didn't spend enough time on the user experience. Now, what developers can do is just spend like 10 or 20% of the time on importing the data, making everything synced, and that's it. The search will work by itself out of the box, and then focus the rest of the time on the user experience. What finally matters for the very user and matters for them. So in terms of API client, we do a distinction. We have two types of API client. We have the backend ones that helps you to import your data and to get it synced between your application and your indices that are hosted on the API side. We also have like framework integration like Symfony and others, connectors for databases, CMS integration to make it even more even easier, and no more need to develop anything, just like it's a plugin, you install it and then you get everything in text. So we are planning to release a few new in the next coming week. And then on the second end, you have front-end API clients, which are more focused on building search experiences. Not much importing data, but really building the search experience. So the main one is the JavaScript one, which is compatible and fully integrated with Angular. We currently even working on Facebook React components, and you can easily integrate it with Twitter typehead. We'll see that later. Select2 and any other jQuery or not jQuery plugin available on the internet, and already doing like some UI search tweaking and so on. And on the second end, you have also like for mobile experiences, we also provide like an Objective-C and an Android SDK. So you can even integrate with search once all your data are pushed very easily within your mobile apps as well. Here's the page with all the integration, so feel free to have a look. A few of them are pushed by the community, so if you want to add your own, feel free to let us know and we'll be happy to post it on this page. Otherwise, just have a look and there are many, and feel free to contribute. Just before digging into the code, just a quick reminder of different two approach in terms of architecture, how to build a search engine. So there is a backend implementation approach, which is basically once you have pushed your data and it's within Algolia here, you can, for instance, say, oh, actually I will use a PHP API client. So every time a user will perform a query, I will asynchronously send a request to my own server, which will perform a request to Algolia, get the response, maybe in some cases do some business logic, DB access, and so on, and then return the result. That works, but actually end up with a very high response time. Most of the time what we see is higher than, greater than 300 milliseconds, and with this value, it's not anymore possible to get instant search experiences, which is so appreciated by users and what people like using services like Google. Nevertheless, there is a second approach that we call front-end implementation that allows you, as new developers, that once you've pushed all your data into Algolia, into your indices, all this data is available, and what you can do is you can, using the API client I just showed before, just instead of passing through your server, just send the query straight to your infrastructure and then get a response. And because we have been designed for speed, with a big focus on speed, and for us milliseconds really matters, you can get a response in less, or around 50 milliseconds, which for the end user means instant response. And that has been possible thanks also our distributed search network, which today includes 12 locations around the world. So you can easily replicate your search instances wherever your users are. And basically, once you've done that, when they perform a search query, it just goes straight to the closest search instance you have replicated somewhere, and then returns the result most of the time in a very quick way. Like what we see is like always less than 50 milliseconds, which is once again the way to provide a real-time search experience. So that's for the theoretical part. So let's see how it looks like in terms of code very quickly. So basically here, I got a page. What we're gonna do is we're gonna try to build an instant search page in 10 minutes. So here, nothing happened except errors. Basically, I want to build this search page here. So the first step for you is just to go on algolia.com open an account. So it's pretty easy. You just click on free trial. Here I'm gonna call it Alex plus Codementor Algolia.com. Any password. Yeah. Then you sign up. Actually, sorry about that. Then you go to a page where you need to select where you want to host your search primarily. So for me, since I'm in France, I'm going to choose Europe in order to get a good response time and a good user experience for my users. So once I've done that, I get on the page where you can already import the first data sample code. But more importantly here, I'm going to use the different credentials that are given by the API in order to import my own set of data. So here, I've already written, as I said before, you can import data through a few lines of code. And it's basically what I'm going to do here. I wrote a quick import.rb Ruby script where basically here I'm going to copy paste my Algolia credentials. So here I take the one that are called admin API key that will allow me to add records. The search only is used on the JavaScript side in order to perform searches and not compromise access to my indices. So here basically once I just initialize the index, the instance of Algolia client, I just initialize the index, I just pass the name, I get the index. Then what I'm gonna do is here I have a file with 10,000 products coming from the Best Buy API, basically, and they're organized in a JSON file. So basically, either you already have a JSON file, or you can also import data from your database. And then the way how it works is you just get everything as a JSON object, or you can ever in each language get it in the native type. So here in Ruby, I could even get it as a hash, and then the API client will serialize. But what I will do here, I will just parse this file, and it's gonna upload here by batch of 1,000 all my records. So I load the files and I split them in batch of 1,000 and gonna push my records 10 times into Algolia. So let's do it. Here I just open my terminal, the right tab. I go to the folder called import and call the script. Basically here, just parse my 10,000 products and push them. And what we can see here is if I refresh my page, I get access to a new tab which is called indices, and that contains all the indices I created with my data. So here we can see that we have 6,000 products already pushed, and we haven't pushed all the products. That search is already available. You can already search through all the records you've added. That's a nice thing. That means that you can push new records all the time. There is no constraint. I mean, like we're reindexing everything on in real time, and that's straight available to the user. So here, if I refresh the page, I get the same search but on 10,000 products. So basically, what you need to push in terms of data, it's pretty easy. You need since like the search engine doesn't do any jointure on its side, what you need to do is push different attributes. You flatten your different attributes from different tables from your database, and then you need to push 4 types of attributes most of the time, at least for a regular use case. The first one are the attributes you want to search for, so name, short description, manufacturer, and so on. Second one are the one you want to use for filtering, like we saw on the previous implementation that it's possible to filter by manufacturer or by categories or by ranked and this kind of thing. So that basically is the second type. And then there is the last type. Obviously also like all the attributes that you want to display at result when you get the results, since you won't do an extra round trip per your server. So here I don't want to search within the image URL, but I still want to have it within the record in order to be able to display the picture. So yeah, that's basically what can be done. And the last one is, as I said before, the strong of building a site search is being able to use numerical value that are business centric and that reveal the popularity of a record. And here it's what we've done with this data set. Here we have a value which is actually on the second. Customer review count, and then we can use that in order to rank all our results. So let's see quickly how it works, and then we'll just jump to the question and answers. So here what we can see is I can search for everything. So I was talking about first step, push the data. So that's done, it's searchable. Now the second step is to just configure, customize a ranking. So here I'm just gonna describe the different attributes in which I want to be able to search in order to increase the relevance. So here I want to search for categories also, like manufacturer, not available. And then what you can do is like you can just simply reorder them. So by doing that, you can make sure that if there is a match in name, the ranking will be higher than if there is a match in category. So that's for the first step. The second step is to tweak, as we said before, the custom ranking, which refers to the ranking. And here we have a value which is it's supposed to be called best-selling rank. Just let me go back here. So here I can just have best-selling rank. And basically here what we see, if I step back to this view, is if I search iPhone, I get the results. And the first one has a best-selling rank of almost 12,000. Here's the second one, 4,000, and then 400. Basically, it's great that all my results are sorted by order of insertion in terms of ranking. So I can tailor that according to my business metric and make it personal and meaningful for my users. So here, by setting up in the custom ranking best-selling rank ascending, what I can see is that basically now when I perform the iPhone search, I get all the records that are matching, but sorted based against this ranking value. So it can be any type of raw value, like the number of sales on the last such days, or the number of connections, the number of likes, the number of followers, or something more advanced. If in the case you have a scoring logic and you are able to compute a score on your side, you can obviously push this as a value and use it exactly in the same way. So that's for the step 2. And now the step 3, I'm just running out of time. So what I do is I'm just gonna basically roll back and just go straight to the point. So here I get the code for my search implementation. So basically a search implementation in order to get things like that, and here we'll display results. What you have one HTML page or several according to your use case. And when you go with a JavaScript implementation, what you have is you have a file which is called JS app, and which used in this the API client in order to perform searches. So here, basically what I do is I'm gonna copy past my application ID here. Now I'm gonna take the search only API key in the UI. So here I can go to credentials. Take the search only API key. This one give only access, a read only access. That's very important to don't confuse the two ones, because otherwise it will give access to everything. And here what I do is I just initialize my index in the helper, so we have a very easy way to handle all the different things using the Algolia search helper. So here my index is called product, so I just specify product. And basically here, in just 200 lines of code, I was planning actually to just to go through all these things together, but we're running out of time. So I'm just gonna show you how it looks like, and then you can always step back. There's a tutorial on Codementor, and we have lots of tutorials also on our website. So here, if I just refresh the page, what I see is like doesn't work, of course. So maybe my index has not the right name. So let's see how my index is called. My index is called products, and I forgot about the S. So here, if I just put products and I go back to my page, just refresh everything, what I can see is I get everything refreshed. And every time I perform a query here, you can search. I can search for iPhone, case, and you get results. And basically, as a developer, what you get is here, you just, every time you perform a new search, let's say I search for S, it just performs a new query that points to Algolia, and as a developer, you get JSON response that contains all the results, and then it's just a matter of display for you. And out of the box, we handle like lots of things really useful for the end user in terms of user experience, and that helps him to search and navigate, like highlighting, pagination, and all this stuff. So here my search looks pretty empty since there is no filter on the left side. Let's see how to enable them quickly. So here I just need to go to play. Basically everything I do with the dashboard today can be done with the API. We are API first, and everything is built on top of our API. So here I'm just gonna add the different attributes I want to facet. So basically I want to be able to filter based on manufacturer, categories, sales price range, maybe also like the customer review count. So I just save, and what the engine does is just recompute all the index. You can see it's real time, and then I get all these facets. So here it's available here, but it's also available if I refresh this page on the implementation itself, because we added here in our implementation a bit of logic here to order the different facets and say how we want to display them. But more importantly, on the search callback, every time there is a search which is performed, what we do is we get a callback with a success or a content, and the content, if there is a success, and we do many things. We render stats, which are this value here. We render the different facets. So here there is a method, a recursive, like there's a loop that just goes through all the facets that are available and just display them. So here you can see that as I'm typing, the facet value is changing. So it just re-updating them in real time. Same for all the rest of the UI. So here, the slider, checkboxes, and here you have something for the pagination. And we haven't added here something that is available also in the tutorial to just refresh the URL every time something is typed. So this URL becomes really easily searchable, at least shareable. So you can share it copy pasting or on social network. So all this stuff are pretty easy to do. Just to go back on the way how it works is you define your client, define your index, then define the helper, and at every new keystroke, so here there's a byting somewhere here. So every time there is on the input, there is a key up or change, what we do is we call the method which is called search, and this method actually what it does, it just calls the helper, the search method of the helper. As a first parameter, we pass a query. Second one, the callback, and any params. Here you can, for example, pass the number of value you want per facet, but it's also the place where you can specify the number of attributes, number of results you want to retrieve per page, and so on. So there are lots of parameters that are available in the documentation, and that you can pass there. So quickly here, if I go back to the different resources, we have basically here integration. Here's the API client I used. We have all this documentation, how to import, how to search in different languages. Instant search demo, all the source code that I've showed you today is available on GitHub. So just after the screencast, you can just download it and try by yourself very easily. We also provide a tutorial for that, which is available here. And just to give you an idea, if you want to build an autocomplete search box, which is a bit different from that, it's as easy and even easier actually to build this autocomplete here that searches for team and players. That means that you will have two indices, one for team, one for player, and that you can import exactly in the same way what I've done before today with the products. And if you rely on plugins already or existing on the internet, like TypeAhead, to get this autocomplete, it's just like all these lines. Here, Algolia initialization and index, then templating, and then you just call TypeAhead, pass a different search parameter you want, like the number of results, and then pass a template, and that's it. And then you can easily get something where at every of my keystroke, I get a result instantly. And that can work on millions of results. It can work on with 10 results or millions of results, doesn't really matter how big is the index, it's always at 3. That's one use case, but obviously you can do that on your own, so you can build your own UI and have a different display, exactly the same. That's the same data set as shown before with the fashion website, or it can even be like something where you mention, like let's say I were Lacoste. Hello? And here you can see there is not to complete, so I just like, as a user, I just pick. So you could mention people, anything, brands, everything, anything you want. So that's for the example, and even like if you want to plug it with other, like select two, it's pretty straightforward. We could imagine to have like something where users are searching for different tags. They can search like California. Here the data set is closed, so it's searching among predictive, like a closed data set, but you can link that with just a few lines of code to your Algolia index and make it searchable across millions of records. Yeah, that's it. That's basically the way how it works and how anyone, a UX developer, a web developer, or even a software engineer can build in a very easy way what we call the real-time search engine with an instant user experience that brings more engagement from the user and also allow website and mobile apps to make their business more prosper. Yeah.
Awesome. Great. Thank you so
Sorry,
much,
I was
Alex.
running out of time. There are lots of things to describe. So,
Oh, no problem. No, this is great, and we have some time left for some questions. I don't think I'd ever seen it load so fast. That the demo, like everything loaded so fast, was so cool. Yeah, I'll go ahead and hit some of the questions. A few different people were asking for some more insight into search on mobile, which is kind of a broad question, but maybe you could talk a little bit more or give some more examples of interesting ways it's being used on mobile.
yeah, sure. Let me just share my mobile. So I'm sharing my screen right now, and I will just put AirPlay and just share it my mobile. So just give me 1 minute. Here my MacBook is available, so it should be fine. That's the way. It's a really good app, Reflector. You can screencast your iPhone. It's awesome. So here, if I search for website I've been already, let's go back to the demo I was showing before, Birchbox, for instance. So here is not a native implementation, but they did a responsive implementation, and basically in exactly the same way they did it for the web, they just did it on mobile. So here I could search exactly in the same way for Paul and Joe. Exactly what I was looking before, and here you can see that I can just scroll the different results. I can see that there is 39 results matching my query, and if I go back and just search as before for perfumes, and I select the result number 1, here it just brings me to a result page where I can navigate, add to the cart, and just like using the facets for just refine that everything in real time. So I can say it's perfume or not. And at every of my click, you can see here, it just get refreshed. And then as a user, I just get in a very visual way all the different facets, the results according to the different filters I can clear. So that's the first implementation, and that has been which has been done on desktop is really easily doable on mobile as well. Here it's just web application, a mobile responsive website. If I go to another implementation, a native one this time, and for instance, Codementor, like here on product tent, I guess you guys know this application. I could easily just press here, search. Vestfox actually use us as their search API on all their devices, so on desktop, on their Chrome extension, on mobile app, so on iOS for now. So I could easily search for Codementor. So here you can see that I search for code, and I haven't typed all the work, but I'm already finding Codementor as a product. There's no collection, but I can even find people working at Codementor. So I could search for Codementor, and then I can type Mark, and Mark seems to be here. So yeah. Is that right?
MacGuffin. I don't know if that's me, but I can see how it works.
Yeah, at least you can get like, here's a founder, and like, yeah, that's the search. And even on mobile, you can easily see that it's pretty easy to implement the same kind of user experience. And what we said is, on mobile it's even more important, because I can misspell Codementor and just like put dash, which is because I don't know, maybe a space, and it's still gonna work. Here you get it as a second result. Yeah. Does that answer your question?
I think so. I think that's helpful. That's a really cool app too. Next question, Juan, who's actually in the room with us, was curious about Spanish language support. So he's wondering, if you have typos or word errors in Spanish.
Yeah, sure.
Yeah, how would that work?
So today the strength of Algolia is that we are completely language agnostic. We work with any written language, including symbol-based languages. That means that Spanish is definitely handled, and you can even build implementation where you install multiple languages in a very easy way. Either you want your user to search for different languages at the same time, or you can say, oh, my user is actually running on my Spanish version, so I will just route him to my Spanish index, or he's running on my German version, and I'm going to route him to my German version. And it's something very easy to do and works exactly the same way that what I've shown before, except that everything gets written in Spanish instead of English. So yeah.
Cool. So a few questions that were emailed then from some other folks. To give people a sense of how all this was being done before something like Algolia, how were sites dealing with search before? Just so we can, we now see how it's happening now, but where were we coming from?
Yeah, sure. So most of the time, like when websites are small, what people do, and they just run like a regular SQL query, and that does a job. But it's a really basic search, because like it's pretty tricky and to handle typo tolerance, concatenation, synonyms, all these features that come with a proper search engine. And otherwise, what people do when they need a more they have a more intense use case, they just rely on available solutions in the market. So either they go with a proprietary solution, which is most of the time a tweaking of an open source solution which has been re-exposed by Amazon, Microsoft, or other foxes on the internet, or they just decide to go by themselves with an open source product with like Solar or Elasticsearch, which are both based on Lucene and are more focused, as I said before, on document search. So basically, that's the way they do. They do that. But it requires lots of skills, time. It's not accessible to anyone, to everyone, and more importantly, it's not been designed for instant search. So it has been designed for search, yes, but not for instant search and what people expect and what people get today on Google, Amazon, or other services.
Gotcha. Yeah, and I mean those statistics you were showing about, how much more revenue they make when they just speed it up a little bit. I mean, that even trickles down to smaller businesses like a lot of us, there's a lot of entrepreneurs that, watch this.
Yeah,
Even
everything.
yeah, even if you're not Amazon, having a faster search can really
Exactly.
impact.
And I
Yeah.
think you guys at Codementor also use Algolia for your search, right?
Yeah, we use it on the site if you're searching for a specific mentor of a specific technology or anything on the site. Yeah. Mal, who is watching the live broadcast, just sent a question in. He or she is wondering, is it easy to implement I18N with Algolia? I believe that's a Ruby on Rails API. Do you know about that?
So, sorry, say again?
Um, are you familiar with I18N? It's a type of Ruby on Rails API, but this person is wondering if it's easy to implement Algolia with that specific tool. But I don't know if
Probably, I don't know this tool particularly, but what I can tell you today is that we have a very well integrated Ruby on Rails integration that plugs to active records. And basically, once you have described your model within the active record, you just put a few more lines of code, and everything gets synced seamlessly. So I'm pretty sure that should work. And if it's not the case, just please get back to us, and we're gonna have a look with you to make it work. But I'm pretty sure it should work. Yeah.
cool. And you guys probably have documentation on your site
That's the
of
nice
what.
thing with web technology is like there's interoperability and like all the things we can mash up and build around and leverage all the different plugins, extensions, frameworks, and so on that are available. And we do our best to be available on all the platform, all the languages, all the framework, and that's where our main focus is for now.
Gotcha. Oh, he just jumped in. It's specifically for internationalization. So you addressed it with a Spanish question. So we're all
Any
good.
other question?
um, yeah. One last question, then we'll wrap up. I think a lot of people are curious about voice search because that's starting to be used more in a lot of different mobile tools. Is that anything different, or has that come across in the same way for Algolia?
I'm sorry, Mark, I cannot hear you. Just like it seems to freeze a lot on my side.
Oh, okay. I'm sorry. Can you hear me better now?
Sounds like my MacBook Retina is not enough powerful.
Okay. All right.
um,
No worries. We
yeah,
we
it's a bit better. Let me just close a few applications. Yeah. Can you just repeat your last sentence? Sorry.
Oh, sure. Well, just one last question. A few people were curious about voice search, since that's starting to be used more in different mobile applications and even some new devices coming out. Does Algolia approach voice search any differently than text?
Actually, we're not focusing on voice search today. What we do is we try to make text search as good as possible, but what's possible is any developer could easily leverage an existing APIs to do voice to text, convert that into a text, and then take the power of Algolia in order to do a voice search. That's something totally doable. I saw a user trying some experiment doing that, and it seems to work pretty well. So yeah, for sure it's possible. Yeah, but it's
Awesome.
something which is not built in our platform. And just like in case Best Foxes would give a try, everyone is able to sign up. We have even a free plan, so you can sign up for free lifetime, and then it's available to you. And all the tutorials I've shown today, there's one on Codementor. We start to have mentors on Codementor, so feel free to have a look. And I think Mark will join to the description. We will probably be able to join the link to this tutorial so people will be able to follow them. And we have an offering a voucher in case of you want to give a try on a more concrete use case. We give you a 250 voucher. So feel free to just give it a try and see how it works for you.
Definitely, yeah. We'll send out links to everybody that
Definitely, yeah. We'll
RSVP'd
send out
with
links to everybody that
with links
RSVP'd
to
with
Algolia and
links
the
to
promo code, things
Algolia
like that.
and the promo code.
Oh, looks like we're getting a lot of echo now. But
Oh,
yeah,
looks
Alex,
like we're getting a
I'll
lot of
let you
echo
go. I don't
now.
want to take
But
too much
yeah,
more of your
Alex,
time.
I'll let you go. I don't want
Thank
to
you
take too
so
much more of
much
your time.
for taking the
But
time
thank
for
you so
this. And
much
like I said,
for taking
everybody,
time for this.
the
And like I
recording of
said,
this will be up
everybody,
on the
the
Codementor YouTube
recording of this
channel,
will
so
be up on
definitely
the
go back and
Codementor YouTube
review.
channel.
And
So definitely go back
we'll
and
be in touch
review.
with more
And
info.
we'll be in touch with more info. All right. Thanks very much. Thanks, guys.
All right, awesome. Take care.
Bye.